Hello and welcome. In this video, we're going to take another look at our parse demo, and specifically, we are going to take a look at how to parse an IPv4 or Internet Protocol version 4 IP address using a command line application in Java. So to begin with, this video assumes that you have been already working on your parse demo. I talk a little bit about the purposes behind parsing a string, parsing a block of text. And in this video, what we're going to do is we're going to focus on the specifics of how to use regular expressions to be able to identify the pattern that we would find in an IP address. Now, this particular example is not going to be a perfect solution. As a matter of fact, we're going to go through a couple of different iterations of this, but this assumes that you've got a working parse demo. Can be part of your fundamentals demo. That's perfectly acceptable. But what we're going to do is we're going to rely on the Java class pattern. Now, a couple of things I'm going to show you in this video are going to be specific to Java, but some of the general concepts are going to be the same for other languages that use regular expressions. And the idea is that we want to be able to identify patterns in a string or patterns in a block of text. This is just one of the first examples that seems rather intuitive or something that we can easily appreciate because we can easily identify an IP address. And to begin with, what we want to do is take a look at what an IPv4 address actually looks like. Now, again, we're not going to go into the networking of it, but I'm basically going to just say that it is a collection of numbers that range in values from 0 to 255, separated by periods. And specifically, it is going to be 4 numeric values separated by periods. And again, they range from 0 to 255. You can see here from the Wikipedia article that it is limited by the number of bits, in this case, 8 bits for each of the octets. The idea is, rather than worry too much about the meaning behind an IP address, what we're going to do is we're going to focus on the pattern, and that is effectively that it is a 1 to 3 digit number, followed by a period, followed by another 1 to 3 digit number, followed by a period, 1 to 3 digit number, followed by a period, and then lastly, a 1 to 3 digit number. Now, I mentioned that we're not going to be having a perfect solution in this particular example. I'm actually not going to limit us to 255. You'll see that we can actually enter in values greater than 255. However, we are going to be limited to the number of digits. In other words, it's going to cap out at 999. Then in a later video, I'll actually show you how to validate the IP address even further. But instead, what we want to do is we want to focus on the idea of a pattern. And if we go back to the Java documentation for the pattern class, you'll see that we have the ability to identify a character class or a class of characters by simply specifying that we are looking for a /d. The idea is that if we are given a string or some input text, then anything that matches a digit from 0 to 9 will be flagged using this /d predefined character class. What we're going to do is we're going to start there, and then we're going to add what we will see as a quantifier that can control then the number of instances of a particular character class we are hoping to find. Now, a little bit of a spoiler alert here. You can see where we're going with this, and that I've already looking at this X here, where that is the character class we're looking for, in this case, a digit. And you'll see that we can match it n, but not more than m times. And if you think about what we had just said a few minutes ago, the idea is that with a IP address, we would have at least 1 digit, but no more than 3. Well, it turns out that this particular quantifier probably makes sense for us. There are some others that we will use in other videos, but again, this is meant to just be a first quick introduction to how to use regular expressions in Java. And also in this link is a little bit of a guide to the classes that we're going to be using. We're going to be roughly following this particular example, although we would definitely be using a different pattern. And we're going to, again, be calling this from the command line. So we're going to go ahead and pass our string to parse on the command line as an argument to our executable. With that being said, let's go ahead and get started here. And so the first thing that we want to notice here that I've given you this little helper function. This is IPv4 that returns a boolean and it accepts an input string. The idea is that we're going to parse that input string looking to see if it matches the pattern of an IPv4 address. And the idea is that we're going to use that pattern class in Java in conjunction with the matcher class to be able to then build a pattern to test against our input string. So let's go ahead and get started, and we'll make some quick notes here. I'm going to start off by first giving you a range of values that we should technically be looking for, starting with 0.0.0.0, and it goes up to 255.255.255.255. Now, again, I want to emphasize that we aren't going to be fully solving this problem in this video because it turns out we're actually going to be able to enter in values greater than that. But again, we're going to come back to that in a later video. So if I were to summarize then the pattern that I would be looking for, it would be 1 to 3 digits followed by a period. And we would actually repeat this pattern 1, 2, 3 times, and then the fourth time we would only have the 1 to 3 digits. And so essentially what we've got here is a human readable explanation of the pattern that we're looking for, and the idea is then we're going to turn this into a regular expression in Java. So to do that, the first thing that we need to do is we need to go ahead and create a variable of type or class java.util.regex or regular expression .pattern. And the first thing that we're going to notice here with this particular class is that it has no constructor. And that's going to seem a little strange in that all it has is these factory methods that we're going to find in our java.util.regex .pattern, and then we're going to have a compile method, and the compile method will allow for us to create a regular expression that we will then apply to our input. Now we're going to go ahead and start with this, and I'm just going to go ahead and set this up with an empty set of double quotes so that we can look at the next piece of this that we're going to be interested in, and that is going to be the java.util.regex. Sorry about that. My autocomplete got away from me there. My regex.matcher. And what the matcher does is it helps us then search the input by calling the pattern dot. And then what we have is we have the ability to get the matcher using the input that we pass to our function. So the idea is that this matcher then will be the matches found when the pattern is applied to the input. Now, before we go any further, I should point out the fact that we really need to do some validation on our input. In other words, we could accidentally pass a null input to this function, and then, of course, then we would get an exception. So you do want to be careful, and you do want to do some basic error checking here. But to keep this video short and to keep it focused on the topic, we're just going to go ahead and skip that. The other thing we want to do then is we want to leverage our found variable. And the idea here is our found variable is going to use that matcher object that we've just created. And we're actually going to explore a couple of different methods. But in this video, we're going to look at the matches method. And the idea is that it attempts to match the entire region against the pattern. Now, this is very important. We're going to see how this plays out in just a little bit when we start doing some examples, but the key word is here that it's going to try to match the entire region against the pattern. And what we're going to do here is we're simply going to leverage that, and we're going to use that found variable to store then the results. And then ultimately then, if we have found equal to true, well, what we want to do is we want to display to the user using a system.out.println some sort of message here. Accidentally did system.error, system.out, and we're just going to indicate that we have found. We'll come back to this in just a second. And then under the else, then we're also going to do another system.out.println with not found. The idea is that this is just going to be a quick, dirty way for us to check to see if the pattern that we are building matches the input that we are passing to our executable. So let's go ahead and get started. We talked a little bit about an IPv4 address. We said that it was compiled of numeric, or comprised rather, of numeric values from 0 to 9, digits from 0 to 9, and there were between 1 to 3 of them. We're going to start very simply. We're going to build this piece by piece. If anything, you're going to see my own personal recipe for how to build a regular expression, sort of piece by piece, testing it as we go along instead of trying to build the entire thing at once. And this is just a good pattern to get into, good habit to get into. And so we're going to go ahead and start off by looking for a single D, in other words, a single digit. And we're going to go ahead and encapsulate this with parentheses. Now, we'll talk a little bit more about why we encapsulate this with parentheses. Please note that these parentheses are inside of the double quotes. And the other thing that we'll need to do is we'll actually need to prefix this slash with a second slash. Now, I encourage you to go back to the Java documentation on the pattern so you can understand the reason for it. I'm going to attempt to explain it. The idea is that we want to have this first slash to indicate that this slash D is a special character class in the regular expression. So if you want to think of it like that first slash exceptions out the second one, that's perfectly fine. But this is the syntax that is going to be used in Java. It is a little bit different, the .NET framework, and also in MATLAB and in other languages that leverage regular expressions. However, most of the pattern portion of the regular expressions, in other words, the special character classes, that's pretty much uniform with the other languages. And so the idea here is that my regular expression is now going to be looking for any single digit in the input string, and this matcher.matches checks to see if it matches the entire pattern. So how are we going to test this? Well, we can come out here to our main, and what we'll do is we'll just borrow either the demo function or create another branch in our else if tree. We're simply going to change this then to the name of the function. I'm just going to go ahead and very carefully copy and paste this here. You'll see this pattern in later videos as well. This is whatever we're looking for, function that returns a boolean. And in this case, what we want to do is we also want to make sure that we have, oops, I changed the wrong one here. My apologies. Let's go back up here to the other one. And we also want to accept an argument count of 2. And the idea is that I want to be able to pass to it the IP address that I ultimately want to check. And then what we can do is we can set up a variable here found in our main. You can see that I already have it because I kind of anticipated that we're going to need this for other functions. And then ultimately what we're going to do then is we're going to call the is function that we've created, passing the arg square brackets, or args square brackets 1, or that second argument, to the command line, and we'll pass it then to our function so that ultimately we can check to see if the user has passed a valid IP address. Now, at this point, we're only looking for a single digit, so let's go ahead and build this. Let's give this a shot. Let's see what does and does not work. I'll try to have the code here as well as the command window. You can see here I'm already in my classes directory, and so what I'm going to do is I'm going to call Java EE333 ParseDemo, and again, if you are in your fundamentals demo, that's perfectly fine as well. We need to remember what our switch is. In this case, it's IsIPv4, and what I'm going to do is I'm going to pass a single number on the command line. So in this case, I'm going to just pass the number 1, and then what we'll see is that we have in fact found it. Now, that's only somewhat reassuring. We don't actually know what we have found. So let's take a second just to see if we can understand a little bit more about what's going on here. I'm going to do another system.out.println. And in this case, what I'm going to do is I'm going to go ahead and print the matcher. And in this case, it's going to seem a little bit strange here what I'm about to do, but I'm simply going to print then the matcher.group, and I'm going to specify that I am looking for the group 0. Now, that'll become relevant in just a little bit. I'm going to go ahead and build this. And I tell you what, I'm going to do one other thing real quick. I'm just going to offset this just by a little bit so that we can indicate then what we are returning. Get a little minor aesthetic detail here. But ultimately then, you can see here that found, in this case, it's found 1. We could test a couple of these. In other words, if I pass 5, it finds 5. If I pass the letter A, of course, it's going to say not found. But what's interesting about this is if I pass then 19, it also says not found. And that probably seems a little strange to you because there is clearly a single digit in 19, but because we have called the function matches, or the method matches on our matcher object, in this case on line 57, well, it turns out that it must match in its entirety. So must match the entire input. And so again, we're going to play around with this. You'll see some benefits of this. You'll actually see in other videos, we're actually going to use another method. But the key thing is it must match the entire input. And so 19 is, in fact, not a single digit. Well, we've got a couple of ways that we can handle this. Obviously, our goal is to pass an IP address to it and actually capture that IP address. So in this case, then, we have to change our pattern. And so to grow our pattern a little bit, I'm going to add a second /d. I'm going to compile it one more time. And I'm going to run it once again. And you can see now I have, in fact, found 19. However, if I go back to attempting to find 1, well, it comes back with not found. And again, that kind of makes sense because we're looking for 2 digits and we are in fact only finding 1. And of course, the same thing happens if you put a couple of letters in here, that's going to say not found. And probably the other thing that we want to check is what happens when we put a combination of characters, and in this case, 2 digits. Well, it again, not found. And why is that? Well, because it must match the entire input. So let's continue to play around a little bit with this pattern. We can go ahead and add a third /d here. And we can build this. And if we run this again, you'll see that, well, the A17 doesn't work, but I can do something like 123, and that will work. But again, any character or any pattern other than that will not be matched, including having less numbers. So in this case, our number 12, we'll see that again is not found. So we have to have a better way of going about doing this. Otherwise, we will never be able to match all the possible IP addresses. And to do that, what we'll do is we'll go back to these quantifiers. And so we started off with the character classes, in this case, the /d. What we want to do is we want to look at the quantifiers. And again, there's a couple of different ones that we can look at. Encourage you to start investigating some of these because we will need these for other patterns, including the question mark, which will match for 0 or 1 instance of a given character class, 0 or more times if you use the asterisk, 1 or more times the plus, and then continue down through all these scenarios. And again, we're at the bracketed ones where n is the minimum number of instances of a character or character class, and m is the maximum. So what we'll do is we'll actually leverage this particular syntax, and rather than, again, hard coding the /ds, and for all the different scenarios we'd be looking at, we'll simply just change this then to curly braces 1, 3, which will allow for us to match anywhere between 1 and 3 instances of a digit. And so again, make sure that you have the matching parentheses on the outside and the matching curly braces on the inside. At this point, let's compile it, let's rerun it, and we'll start off with our 1 again. 1 works, 12 works, and in this case, 123 also works. But if I try to put in 1, 2, 3, 4, well, it's not going to work. And then any other combination, including a combination of letters and numbers, will also not work. So you can see here we've made some slight improvement in our pattern. We're getting ourselves ever so closer to being able to discover the pattern for an IP address. So if we continue now with our comments that we wrote out earlier and going back to the Wikipedia page to understand how an IPv4 address works, you'll see that you can simply add then the period. And so we'll carefully do this. We'll actually put the period again inside the parentheses. And we'll recompile this one more time. We'll come out to the command window. And sure enough, our 123 now, one second here, our 123 will work. There we go, will work, as well as the 123 period. And then 123 with the letter A after it will also work. And so that's not exactly what we wanted to have happen. We wanted to use only a period to separate our numbers. And so you're probably a little confused why this doesn't work. Well, once again, we're going to bounce back to the Java documentation, and you'll see if you scroll up that the period itself can be used to define any character which may or may not match the line terminators. In this case, this is what is accidentally allowing for us to put any character after our three numbers. Now, you're probably wondering how in the world we're going to specify that we want exactly a period. And well, it turns out there's a couple of ways to go about doing that. We're going to keep it pretty simple, but again, simply putting in a pair of slashes right before the period. And then essentially what that says is that I want a period and nothing but a period. And so if we rerun this one more time with our 123A, well, it's not going to be found. Whereas if we swap out the A for a period, it now identifies it as a period and only a period. So continuing on with this pattern here, we can go ahead and very carefully copy and paste this, much like we did with our comments. And so that we want to duplicate now the pattern of 1 to 3 numbers followed by a period, 1 to 3 numbers followed by a period. We can go ahead and build this. And what we're going to do is carefully see if we can construct an IP address. And what we'll do here is I'll start to give us some meaningful IP addresses. There's actually a couple things we can do here. If you're on a Windows machine, you can simply type in ipconfig /all, and you can see the IP address, or excuse me, the network adapter configuration for your laptop or your desktop. And you can see that there's a number of IP addresses that we could use. In this case, what I'm going to do is I'm actually going to go ahead and borrow, for instance, my IP address for my router at home, the 192.168.1.254. There's nothing really magical about that. You can use any of the IP addresses that you saw on the Wikipedia page. But again, I'm trying to just give you some purpose behind this, and you'll see that it does in fact not find it. However, if I'm very careful and limit it only to 1 to 3 numbers followed by a period, and then 1 to 3 numbers followed by a period, well, it does in fact find that. And so you can see that our pattern is getting closer to what we're ultimately trying to capture. And you can, again, just very carefully duplicate this pattern for the third octet. And at this point, you've probably guessed what we'll need to do for that fourth one, and that we're going to very carefully just go in and copy and paste just the D or the integer part and not that final period. At this point, if we build it and again, run this from the command line, you'll see that it now matches the entire IP address. And what we'd like to do now is we'd like to actually see a couple of variations of this, not only of our regular expression, but what we'll do is we'll start off by breaking this up into smaller pieces. And again, also seeing some of the limitations of this particular regular expression. So we'll start first with the regular expression limitations. And as I mentioned earlier, that an IP address should be bound by 0 to 255. And what you're going to see is for our particular pattern, 999.999.999.999 will also, in fact, be registered as a valid IP address. We know for sure if you read through the documentation, if you've got any experience with working in networking, you'll know that that, in fact, is not a valid IP address. So we've got a couple of things that we need to work through. And so what I'd like to do is I'd like to change my regular expression ever so slightly and dig a little bit deeper into this matcher group. And I'm just simply going to copy and paste the first line here where I've defined my pattern. And I'm going to carefully go in and around each one of the numeric values. I'm simply going to put a set of parentheses, or rather an extra set of parentheses. And what this is going to allow for us to do is to capture each of the portions of the IP address separately. And to understand what I mean by this, what we will do is, if in fact the matcher matches, give me 1 second here, appear to have a typo. Yes, there we go. Too many parentheses there. If in fact the matcher does match the pattern, what we would like to do is, in addition to putting in the system.out.println found, we also simply want to indicate how many matches, or groups rather, it did find. And so what we'll do is we'll do another system.out.println, and we will simply specify the matcher dot group count, and the group count will tell us then how many pieces are there, if you would, in our match results. And so I'm going to go ahead and take a second and make this look a little nicer here, our count. And at this point, then what we can do is we can build it once again, and we're going to play around with this regular expression a couple of times here to see, now that we have a working regular expression, what the differences are. Notice I have 4 sets of parentheses, and you can see now my count is 4. If you want to understand what the difference between these two are, I'm simply going to comment out the first one, change it back. I'm going to rebuild it, and with the original pattern, our matched count is in fact only 1. And so the parentheses, as you can see now, control what we are in fact actually capturing out of the input. Now, before we go any further, I would like to take just a second to change this up just slightly. In other words, I'm going to put some additional text in front of here. In other words, I'm going to try to make it look a little bit like that output from the IP config all, although not looking for anything specific. I'm going to just specify that my IP address is this. In other words, basically try to make it a little more human readable. And interestingly enough, now we are back to where it says not found. So it's very important to note before we go any further that with the matcher.matches, the pattern must be matched exactly for the entire input. So effectively what this does is this allows for you to look at a small piece of text, in this case a small string, to be able to determine whether that particular string is in fact an IP address. It doesn't tell you whether there is an IP address in a bigger block of text. We'll leave that for a later video. The other thing that I want to do is, while we're on this subject, I want to switch us back over to the regular expression that has the 4 sets of parentheses. And again, what we want to do is test it and remind ourselves that we have a count of 4. Now, that just simply means that we're capturing 4 individual things in our regular expression. And that probably doesn't make a lot of sense to you yet. What we're going to do is we're going to take this matcher group count and we're going to use it to drive a for loop. Now you'll notice here that what I've done is I've actually hard-coded that 0th element in the print line. And if you right-click on the group count and go to source, you'll see that in the documentation, what it does is it denotes the entire pattern. Group 0 denotes the entire pattern by convention. In other words, basically what it does is it tells us that the group 0 is effectively the entire pattern that was matched, and the group count tells you how many additional patterns or sub-patterns were found in the input. Put another way, it means that the text that we passed, in this case, our input string, was matched in its entirety by this regular expression, and the 4 elements, additional elements, are represented by these 4 substrings or subpatterns within the greater pattern. And there's, again, a number of different ways that we can describe this, but to understand what's going on, we're simply going to set up a for loop by going for int index equal, and we're going to start off at 1, and we're going to have the index continue or less than or equal to our matcher dot group count, and much like in any of other for loops, we are going to increment our index. And then what we'll do is we'll use our system.out.println, and we're going to indent this a little bit further so we can see the difference between the two. And we're going to specify then the matcher.group, and we're going to specify using the index the additional substrings or partial strings that represent each of the individual numbers. Now I'm going to go ahead and build this. I'm just going to go ahead and run it. And hopefully what I've explained kind of makes sense, because now what we're going to see is the entire IP address that was matched, as well as the smaller pieces, the 192.168.1.254. Now I'm not going to do that in this particular video, but at this point, you should see that you can convert those strings then to integers and then just simply check the values to make sure that they are between 0 and 255 inclusive. But now what we want to do is remember and come back to our main to appreciate then what we're really trying to do here is if the found is in fact true, well, we'll just have a little bit of an if statement in here. So if found is true, then we'll have another system.out.println, and we'll say that the input is an IPv4 address, and under the else, well, the input is not an IPv4 address. And again, just a little bit of flavor, a little bit of embellishment, if you would, in our application. But at this point, then, if we rerun it, well, you can see there that input is an IPv4 address. And if we do something to change that, for instance, if I replace that last octet with a letter A, or if I try to use something that would not make any sense here, so 1, 2, 3, 4, I'll again get the prompt that says input is not a IP or not an IPv4 address. Now, at this point, there's plenty of different ways we can take this topic. We can use this for validation. You'll see that later videos, I'm actually going to show you how to parse a larger block of text and return an array of information as well as an array list of information. But the idea here is that this gives us a start now with our regular expressions. And the key thing that you want to do when finishing up this video is make sure that you understand the concept of this pattern using regular expressions. The regular expressions themselves are a relatively common language among other platforms. Some of the character classes are a little bit different, and some of the behaviors a little bit different. And the big thing that's unique in Java, or relatively unique in Java, is the need for the double slashes in front of some of the character classes. Again, minor details. I would say that there's probably about 90% similarity between how Java does regular expressions, .NET does regular expressions, and MATLAB does regular expressions. The main thing to note is that regular expressions are an incredibly powerful way to do pattern matching. I'm pretty sure you could probably figure out a way to do the exact same thing using an algorithm. But again, the flexibility of the regular expressions is much greater and much easier to use. So hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.